So today we are talking about what we call rational functions. Okay, rational functions. What are rational functions? They're fractions, basically. The word rational means fraction. Okay, so everything we do today we'll talk about fractions. So fractions by themselves are not bad. The only time fractions are bad is if x winds up in the denominator. So fractions are not really very difficult at all. It's when x is in the denominator. So there's a problem with this one, 1 over x. So if x, just think about this, if x equaled 0, we would have f of 0 equals 1 over 0, and that is bad. What happens when you divide by 0? Well, one of two things. You either get an asymptote or you get a 0, okay, now, or a whole. Now, as far as a whole, we'll talk about that later. But if I were to put this in my calculator, just take a look at it. Okay, y equals clear, 1 divided by x. Get my window to a normal window, negative 2 to 2, and negative 2 to 2. I want you to see this. So it looks like this. So what we don't see is what's happening to the graph as it goes up. So let me change my graph window a little bit more. Let's go from negative 10 to 10 and do another negative 10 to 10. So you get a good visual of, okay, so it's kind of going like that. So something weird happens right here at 0. And so as you divide by 0, this part of the graph goes off to infinity. And as you divide by 0 this way, this graph goes off towards negative infinity. It never ever gets to negative infinity and never gets to 0, okay? The same thing with the horizontal asymptotes. It gets closer and closer to 0. It gets closer and closer to 0. So we get two asymptotes right now. Why does it go to infinity? Let me give you a super easy explanation, okay? Listen to what I say, okay? I have one piece of paper. Divide it into halves. Divide it into halves. How many halves do you have? Divide this into halves. How many halves do you have? 2. So 1 divided by 1/2 is 2. And a lot of kids get confused by that, but it really makes sense. This piece of paper, divided into tenths. Tenths. How many pieces am I going to have? 10. So 1 divided by 1/10 is 10. Again, a lot of kids get confused because they think when you divide, you're going to get a smaller number, right? But really dividing it up into pieces, right? So I have this piece of paper divided into hundredths. Now that's pretty little, but how many pieces would I have? That's a lot of pieces, but they're super small pieces, right? So if I divide this piece of paper into millionths, now the millionths are like itty bitty things, right? But how many pieces would I have? So as I divide 1 by bigger and bigger numbers, it gets closer and closer to 0. But if I divide something that gets smaller, closer and closer to 0 by 0.1, 0.01, I get bigger and bigger numbers. So as I take my graph and divide it by smaller and smaller numbers, it gets bigger and bigger, it approaches infinity. So the graph looks something like this. And of course, we can also divide it with negatives, and the other half of the graph looks like this. But there are two things on this graph we need to recognize, and that's our asymptotes, okay? So let's take a look at the asymptotes. So an asymptote is where you divide by 0, or it's a line of infinity. So an asymptote we put in as a dashed line, okay? Actually, I'll use a different color so you can see it better. But the asymptote itself is a boundary line. It's not part of the graph, it's a boundary line. So as my function gets closer to 0, it goes off towards infinity. It never gets there, but it gets closer and closer to infinity, okay? And the same thing as my function gets closer and closer to 0 on the negative side, it gets closer and closer to negative infinity. So the asymptotes are only boundary line. Now we have a second asymptote, and that's my horizontal asymptote. If I take 1 divided by 100, I get a pretty small number, right? If I get 1 divided by 1,000, I get an even smaller number. So as x gets bigger and bigger, the value of y gets smaller and smaller and smaller. But I'll never get to 0. 1 divided by what is going to give me 0? 1 divided 0? Seriously? Bummer! So 1 divided by what gives me 0? 1 divided by 1? So one more time. 1 divided by what gives me 0? Nothing. So that means there is nothing that we can get for an answer of 0. So we get another asymptote, a horizontal asymptote at 0. So here's the thing. We have two asymptotes. We've got a vertical asymptote. And that's this one here. That's when I divide by 0. That's when you divide by 0. And then we have a vertical asymptote also. Okay, so we've got a vertical asymptote.
Horizontal.
I'm sorry. Thank you, Marie. I'm so glad you're here. We have a horizontal asymptote. And that is when x approaches infinity and the value of y becomes, well, it levels up. We're not going to say 0 because at some point it becomes something, but it levels off, okay? Now, example 2 is this graph. This is my parent graph, okay? So we want to take this graph and we can actually move it around. But before we even do that, though, one thing I know for sure is x cannot equal -2. X cannot equal -2. Can't. If x were -2, we'd have -2 plus 2 is 0. 1 divided by 0 would be a sad thing. It's going to kick your asymptote, right? So we know right at the bat that we're going to have, at -2, we're going to have a vertical asymptote. So where you divide by 0 will have a vertical asymptote. So I put my vertical asymptote in right here, okay? Now, if x goes to infinity, if x gets bigger and bigger and bigger, then this value gets smaller and smaller. This value actually goes to 0. As x gets bigger and bigger and bigger, we get 1 divided by 100 divided by 2. I get 1 divided by 1,000 plus 2. 1 divided by 1,000,000 plus 2 is basically this value here is going to go to 0. So we'd have a horizontal asymptote at 3. So I can put my 1, 2, 3, and I get a horizontal asymptote. Now, it's the exact same graph, so it just fits right in there. So my function then, let's see if I can get, let's see, how about this color? This will work. So my graph should look like this. Now, if we're not convinced, right, Lane's going to say, Lane, you rightfully say, well, I'm just going to graph it, right?
Yes.
So if we don't believe Mr. Davies, say, well, shoot, I'll just graph it, right? Y equals clear, and if I go 3 plus 1 divided by parentheses, right? X plus 2. Okay. Now in this one, you got a kind of weird looking thing right here. What do you think the calculus is trying to give me right here? Yeah, it's an asymptote, right? Do you see how it levels off here? Now, the calculator doesn't always draw an asymptote because the asymptote is not part of the graph, right? So it also looks like I have a horizontal asymptote there. See how it levels off? And it levels off at 3, doesn't it? Okay, there's the graph side by side, and there's my vertical asymptote, okay? All right, now, and one real quick, if you had f of x equals -1 over x, okay, real quick, I'll throw that one in. I want to see the negative. How can you guys, what do you think? How is this function different from this function here with the -1?
-1.
You're very close. If you rotate it, though, it becomes itself. You're very close.
Oh, I'm saying, like, you flip it.
Flip it. There you go. Yes, it's a flip. It's just this graph and this graph. Okay, does that make sense? That's all it is. It's just a flip over the x-axis. Okay, that's all it is. Now, so let's go ahead and back to f of x equals 3 plus 1 over x plus 2. Because it says describe the translation. So we want to describe the translation from 1 over x to this graph, 3 plus 1 over x plus 2. So what happened? What happened in this graph right here? What happened? It got moved. Where did it get moved to? This graph got moved, didn't it?
Over 2 up 3.
It went to the left 2 and up 3, right? So if I describe the translation, I would say the function moved back 2 and up 3, right? Now, what about the equations for the vertical and horizontal asymptote? So I really do have both. Okay, now the vertical asymptote, the one that goes straight up and down, is an x-equal equation. So the vertical asymptote of this one, the vertical is just an equation, x equals -2, right? If you had to graph that line that goes straight up and down, that's an x equal -2, right? You guys remember doing that? Graphing those? Yeah, and then what's the horizontal equation of the horizontal asymptote? Yeah, it's just y equals 3. So this horizontal one is simply going to be y equals 3. Easy? Thumbs up? Okay, so remember, don't divide by 0, because if you do divide by 0, you're going to get an asymptote, all right? Turn the page. Divide by 0. Okay, now, number 3. So, find the horizontal. So first of all, before we do anything, the vertical, let's look at this one. My vertical, yeah, thank you. Let's look at the vertical asymptotes first. Okay. So my vertical asymptote, all right? So if I had to do the vertical asymptote, I'm going to ask myself, don't divide by 0. Don't divide by 0. So if you divide by 0, it's going to kick your asymptote. So where would I divide by 0? You guys agree with Will? Okay. So at x equals -2, there has to be a vertical asymptote. Has to be. And again, we can graph it and look at it. But at -2, you'd have a -2 plus 2 makes 0, right? So for sure, we're going to have a vertical asymptote at -2. Now, for the horizontal asymptote, I'm going to flip the page and then flip it back. Okay, if I flip the page, what we found on this function here is when x got really, really big, this part of the fraction just kind of became 0, and the horizontal asymptote was at 3. Okay, so when it was in this form of a number plus something, the horizontal asymptote really became the 3 because all of this became 0 as x went to infinity. So what I want to do here is divide. So if I divide, I can get it into this kind of form. So let's go ahead. So let's divide this. Let's see if you remember anything from last week. Let's divide. How do you divide? We could do that. You're so close. Not substitution, but starts with an S. Starts with an S.
Synthetic division.
Let's do synthetic division. Let's go. That's what you meant, wasn't it?
Yeah.
Yeah.
Same thing.
I knew that's what you meant. Let's go -2 into 3, 5, right? Let's do synthetic division. Now, it's a really simple little synthetic division, but we can do it, okay? All right, we're going to do synthetic division. We take the opposite, remember? Bring down 3. 3 times -2 is a -6. 5 and -6 makes a -1. So it really becomes f of x equals -3 plus a -1 over x plus 2. All right. Now let me show you something. I really want you to understand why. So if you think about the graph, okay, watch and think really hard about this, okay? If you think about these graphs, as x goes to infinity, you find your asymptote. As x goes to infinity, you find your asymptote, right? So let's put really big numbers in here for fun, just for fun. So 3 plus -1 divided by parentheses. Give me a big number. 64 plus 2. I need about 2.98. Okay?
Do you want another one?
Sure. 3 plus -1 divided by. Give me a bigger number.
1,224.
1,224 plus 2. Okay, so all I'm doing is plugging in your numbers here, right? 2.999, right? So give me a bigger number. 3 plus.
10 million.
Okay, 10. All right. All right, 10 million. 10. No, I don't know about how about that big number? Plus, don't forget plus 2.
Well, no.
Basically 3. So what happens is x gets bigger and bigger and bigger. This whole thing here really becomes 0. Plus 3 is 3. So my horizontal asymptote happens when x approaches infinity, and in this case we get y equals 3. Now write this down, okay? Write this down. Okay? 1 divided by 0 is equal to infinity, and 1 divided by infinity is equal to 0, okay? Write that down. 1 divided by 0 is infinity, and 1 divided by infinity is 0. Okay, actually I lied a little bit, but for us right now, we're going to go along with it. I lied because you can't divide by 0 because you can't get to infinity, right? Infinity is not a number, so it's not really equals, it's really approaches. And you can't really divide by infinity because infinity is not a number, right? But for our purposes, this works, okay? So graph the function. So if I graph this function, all right, let me get out a ruler here. Let's put down what we know, all right? So, Lane, I could put on my calculator. I could, but I'm going to do it without a calculator because, you know, we're smart, right? So on this graph, I'm going to have a horizontal asymptote at 3, right? 1, 2, 3. So I'm going to put in my horizontal asymptote. We're going to put a vertical asymptote at -2, right? It has a negative here, so it's upside down. So my graph must look something like this. Now, if I'm wrong, I can check it on the calculator, right? I don't think I am. I think I'm pretty confident I'm right. But so let's graph it. Let's see what the calculator says, okay? So let's see if we're close. So the calculator, y equals, clear that, parentheses, 3x plus 5, right, divided by parentheses, x plus 2, and let's see what we get. Graph. Does it look like what I just graphed?
Yep.
It does. You can see the vertical asymptote, right? And the horizontal is there. See, it's leveling out. Because it doesn't draw it, but it's leveling out at a height of 3, right? Thumbs up? So the moral of the story is this. Don't divide by 0. Otherwise, it's going to kick your asymptote, all right? Good.
The key is you gotta pause there, ask,
Yes, yes.